We are the main shrewd life in the known universe. Envision that we're the key spot where there is data in this limitless system. Cosmologists throughout the world are in wonderment of this always advancing divulgence. The James Webb Space Telescope has captured the unobtrusive shine of city lights, an inconceivable 7 trillion miles away from Earth, beating all doubts. This astonishing accomplishment does more than simply expand our viewpoints in terms of what we know about the universe. Hypothesis goes wild as researchers pore over the information looking for signs that could open the secrets of these confounding great guides. The ideas are astonishing. Could it be that we are following in the footsteps of some great people in the universe, and that the universe is teeming with life and movement very far outside our ability to grasp? Is it conceivable that these distant lights show the presence of extraterrestrial social orders? What's the importance here for our insight into the probability of life in the universe beyond Earth? Join us as we look at how the James Webb Telescope just saw city lights 7 trillion miles away. Launched into space on Christmas Day 2021, the James Webb Space Telescope, JWST, was designed to beat the highly regarded Hubble telescope in capturing astoundingly sharp photographs of newly discovered brilliant objects, planetary systems, and more. A clear goal of the JWST is to focus on the progression of the earliest universes by examining the far-off nearby inhabitants of the universe. This is pragmatic because the journey time of light throughout our universe is billions of years. When the JWST gathers light, it captures these objects precisely as they were billions of years ago. Space experts measure distances in light years, which is the best distance light can travel in a year. To illustrate this reality, the mission's first major practical attempt was a massive field picture that was introduced on July 11, 2022, by U.S. President Joseph Biden while he was speaking from the White House. While the Hubble Space Telescope focused on a single region of the sky for 10 straight days starting on December 18, 1995, the Hubble Deep Field acquired fame. The region was just a tiny spot making up around 1/millionth of the whole sky. Most of the 3,000 currently invisible things found by Hubble were gigantic systems found billions of light years away. With its focus on the SMX 0723 galaxy cluster, the JWST Deep Field covers a similarly small sky region. The galaxy structure SMX 0723 is 4.6 billion light years away, and the more distant galaxies behind it are magnified by the intense gravitational field. The foundation of the admirable systems is distorted into massive turns where the gravitational field is most intense. In one case, it was confirmed that it took a distant world's light 13.1 billion years to reach the telescope. The primary goal of the JWST has been to capture visible light from their stars into the infrared. Stargazers can clearly distinguish JWST and visible light photographs of nearby universes taken by Hubble and other telescopes. By gathering information at those frequencies, we can see how universes have evolved over vast timescales and continue merging into the shapes we notice today. More astonishing than the sheer number of structures in the JWST's first deep field image is how quickly it was captured, in just hours compared to days or even weeks for other telescopes. Wherever it looks, it can't resist the temptation to track down galaxies. Galaxy clusters aren't the only objects acting as magnifying focal points. Experts utilized the JWST to capture a picture of several galaxies designated VV1191, so they could study how the light from one of the pair changed as it passed through the other. The results of this study will reveal the properties of the intervening galaxy development. Moreover, it seems that the JWST may have actually made an extraordinary discovery. Light from a very distant system has led to the declaration of the possible presence of auroras on an exoplanet, as announced on the official JWST website. The absence of a host star and the frigid temperature make it difficult to pinpoint where the energy in the upper atmosphere is coming from. However, the fact that the object exhibiting auroras is indeed emitting methane is crucial. Just like auroras on Earth are caused when energetic particles traveling from the sun into space are caught by our planet's magnetic field, the charged particles then make their way through Earth's atmosphere near the poles, where they collide with gas particles, creating a brilliant light display called the aurora borealis. Jupiter and Saturn have similar auroral anomalies due to the solar wind. However, the mysterious W1935 has no star to orbit, so its auroras are a huge mystery. Everyone's suspicion continues to focus on Proxima Centauri and TRAPPIST-1, approximately 4.4 light-years from Earth within the Milky Way galaxy. Experts have identified the presence of water on the exoplanet, and the chance of life on the planet can't be ruled out. Are we finally going to see proof of life beyond Earth? Just last month, the JWST observed another incredibly massive black hole. This enormous black hole was observed in various wavelengths and is consuming everything around it. This discovery is 40 million times as broad as the Sun. But what does this mean for us? The JWST has found that this supermassive black hole has been present since the beginning of the universe. It likely won't be moving. This beast is rapidly consuming everything in its nearby district. The discovery was made by Dr. Lucas Fu and Professor Alastair Z of the Ben Gurion University of the Negev in Israel. According to their findings, the supermassive black hole is nearly 30 times heavier than the Sun, making it a gigantic entity. Fortunately, it is located a great distance from Earth, around 129 billion light-years away. Still, it is drawing nearer with the black hole consuming everything around it at a rapid rate, as indicated by the red shift. When the JWST began sending back its hidden data, researchers were excited as they sifted through the information that came in for the uncovered program. 3 small objects with a faint red flicker caught their attention. They immediately believed it was a nearby massive black hole. However, when they analyzed the data using gravitational lensing, they discovered something much more fascinating. The discovery of similar phenomena in other early universe supermassive black holes has provided new insights into the progression of both the black hole and its host galaxy, as well as the relationship between the two. This is still largely mysterious, but it could be evidence of the early-stage formation of massive objects, like star-forming materials that fell into black holes. Space experts cannot yet see exactly what is going on in the images returned to Earth, but one thing is clear. The James Webb Space Telescope is constantly finding new strange objects every day. We have the pleasure of exploring space and being enchanted by the dazzling lights of planets and stars that float across the universe, light years away. Not only does the JWST allow us to see far beyond what our eyes can comprehend, but it has also revealed a mysterious object in one image. This image, which focused on something entirely different, was taken by the European Space Agency, observing 2 young stars forming about 1.47 light-years from Earth. However, there is a tiny orange mark at the bottom of the image that appears to resemble a question mark. Clearly, this small image is far from insignificant. In fact, it's enormous. The question mark shape was captured while observing the arrangements of young stars known as Herbig-Haro objects, which are surrounded by vast rings of gas and dust. As for the question mark shape itself, it could be that, due to the two-dimensional image presented by Webb, it appears in this way from its specific perspective. At this moment, we have no idea what it is, and without further study, we may never know. However, the discovery has been validated by specialists, and it is likely a distant structure or perhaps galaxies that are interacting with each other. The disrupted question mark shape could be a result of their coordinated efforts. Given the surge of distant exaggerated structures revealed by Webb, there is an ongoing flood of new predictable inquiries. Everyone's eyes are focusing on a specific set of Earth-sized planets that could hold the key to finding extraterrestrial life. The persistent dilemma, which includes the lack of proof for advanced extraterrestrial life in the universe despite the high likelihood that such creatures exist, could finally be resolved. Where are these planets? They sit exactly 40 light-years from Earth, and the nearby star system is known as TRAPPIST-1, which has 7 planets orbiting it. In their quest to find habitable planets, NASA is considering a wide range of criteria beyond a planet's size and distance from its star. A more reasonable approach is to evaluate the overall conditions of the planet's atmosphere, as this would allow scientists to determine whether the planet is habitable. The Infrared Spitzer Space Telescope, which is part of NASA's space exploration mission, helped reveal the 7 harsh exoplanets orbiting the same star, TRAPPIST-1, years ago. The James Webb Space Telescope has now measured the temperature of TRAPPIST-1b, one of those planets. JWST has consistently made groundbreaking discoveries since its launch, and this finding is just the latest in a series of record-breaking firsts. This is the first discovery of light emitted by an exoplanet as small and cool as those in our own solar system. No other telescopes have had the ability to measure such faint mid-infrared light. Space experts were thrilled when they first learned about the 7 TRAPPIST-1 exoplanets, as these distant worlds are all Earth-sized and reside in the habitable zone, the region where planets can have liquid water on their surfaces. However, the TRAPPIST-1 planets are beyond our current reach, located a staggering 235 trillion miles away. They orbit a star much smaller and redder than our Sun, known as an M-dwarf star. These stars are far more common in the Milky Way than Sun-like stars and are ideal targets for planet hunters. However, M-dwarfs are also more prone to flaring and sending high-energy radiation, which could be damaging to emerging extraterrestrial life or a planet's atmosphere. When we turn our attention to TRAPPIST-1b, we find that it is tidally locked to its star. One side of the planet is always facing the star, while the other remains in constant darkness. This difference in temperature creates extreme conditions, with the daytime side reaching temperatures hot enough to melt iron. The dark side remains much cooler, but still hot enough to prevent the formation of methane, a key atmospheric gas. Although this may diminish the planet's potential for harboring life, the JWST's ability to measure these extreme conditions offers a unique view of distant exoplanets and their atmospheres. As we continue to push the boundaries of space exploration, the James Webb Space Telescope, JWST, offers unprecedented insights into the mysteries of the cosmos. One of its most remarkable abilities is to peer into the distant past, capturing light from objects that have existed for billions of years. This capability allows scientists to study the formation and evolution of galaxies, stars, and planetary systems with a level of detail never before possible. Each new image and discovery reveals more about the universe's vast complexity, sparking new questions and fueling our curiosity about what lies beyond. One of the primary goals of the JWST is to study the early universe, focusing on objects from the first few 100 million years after the Big Bang. In particular, researchers are looking for the first galaxies that formed after the universe's initial expansion. By examining the light emitted by these ancient objects, scientists hope to uncover clues about how galaxies, stars, and even planets began to take shape. The JWST's infrared capabilities make it especially suited for this task, as it can detect the faint, red-shifted light from these distant galaxies, which has stretched over billions of years due to the expansion of the universe. In addition to studying distant galaxies, the JWST is also providing invaluable data on exoplanets and their atmospheres. Its sensitivity to infrared light allows it to study the chemical makeup of distant planets, which is essential for understanding their potential to harbor life. By analyzing the light that passes through the atmospheres of exoplanets, the telescope can identify key chemical compounds like water vapor, carbon dioxide, methane, and oxygen molecules that are crucial for life as we know it. These findings offer tantalizing clues about the possibility of life beyond Earth. Another significant aspect of the JWST's mission is its ability to explore the formation of stars and planetary systems. Within vast molecular clouds of gas and dust, new stars are born. The JWST can peer into these clouds to observe the earliest stages of star formation, providing insights into the conditions that lead to the birth of new suns and, potentially, new worlds. The telescope's ability to see through dense clouds of gas and dust, which often obscure observations in visible light, makes it a powerful tool for studying these processes. Moreover, the JWST is also advancing our understanding of black holes, particularly supermassive black holes that reside at the centers of most galaxies. These cosmic giants are thought to play a critical role in the formation and evolution of galaxies. By studying the behavior of the material around black holes, including the powerful jets and accretion disks they generate, scientists can gain a deeper understanding of the forces at work in these extreme environments. The JWST has already made significant strides in observing distant supermassive black holes, providing a clearer picture of their growth and the impact they have on their host galaxies. While the JWST's discoveries have primarily focused on deep space, its observations also have practical implications for our understanding of Earth's place in the universe. By studying the atmospheres of exoplanets, astronomers can gain insights into the conditions that could make a planet habitable. This research also contributes to the ongoing search for extraterrestrial life. For example, The discovery of certain gases in an exoplanet's atmosphere could signal biological activity, similar to how Earth's atmosphere contains a mixture of gases that are indicative of life. The telescope's ability to observe such distant and faint objects also helps scientists refine their models of the universe. As we gather more data about the formation of galaxies, stars, and planetary systems, we can test our current theories and adjust them based on new observations. The JWST's findings may even lead to the development of entirely new theories about the nature of the universe, challenging our understanding of fundamental concepts like dark matter and dark energy. In the coming years, the JWST will continue to provide groundbreaking insights into the universe's deepest mysteries. As more data is collected and analyzed, scientists are confident that the telescope will unveil even more astonishing discoveries. The possibilities are endless, from identifying potentially habitable planets to uncovering the secrets of galaxy formation. The JWST is opening a new era of astronomical exploration. As we look to the future, it is clear that the telescope will play a pivotal role in our quest to understand the cosmos and our place within it. With each new revelation, we come one step closer to answering some of humanity's oldest and most profound questions. Are we alone in the universe? What lies beyond the stars? And how did the universe as we know it come to be?